Hello everyone. Hello everyone. My name is Shafaa, and today I will be representing my research optimization of flat rolling process through a simulation approach using Simufact forming with Dr. Jaber and Dr. Aiman from UAE University. We will start with our agenda. We'll start with an introduction, then the simulation model and the results, and lastly we'll talk about the conclusions. So, what is flat rolling? Flat rolling is one of the basic rolling processes out there. It reduces the thickness from an initial to a final thickness. We have two types. We have hot flat rolling and cold flat rolling. They both depend on the recrystallization temperature. So, if the working temperature is higher than the recrystallization temperature, then it's considered hot flat rolling, and if it's lower, then it's considered cold flat rolling. So this is a schematic, a simple schematic of the process. We have an initial and final thickness, and we have the rolling direction. We have two rollers rolling in opposite direction, and we have the contact angle and the contact surface between the rollers and metal stock. We did use Simufact forming for the simulation model. So 2D planar simulation was used. It was considered a hot process at up to 1000 Celsius Celsius for the workpiece. So the tubular motion press, which is initializing the contact between the metal stock and the rollers of 4000 Newton, and the tubular motion for the rollers, which is a specified RPM for the rollers for a specified amount of time, and then the column friction between the rollers and the workpiece, and finally a quiet mesh for the workpiece with the element size of 0.5 mm. This was expanded to 3D. The parameters, so we did change the roller rotational speed and the friction coefficient. The material was one of the ones in the library of Simufact forming, and an initial and final thickness was 40 to 10 mm. So the results, so the rolling force did exhibit almost a linear relationship between the two varied parameters. So we would say that intermediate values here are the best, because you don't really want very high rotational speed or very low or high friction coefficients. As for the stress and elastic strain, as you can see, the strain didn't really change. There's very minimum variation between each values, but as for the stress, it did change significantly. We have here almost like a quadratic or a linear relationship. So we would say that intermediate values also here are the best. Intermediate values here are the best because this positive quadratic relationship, and it would exhibit a minimum around this area. And lateral spreading isn't very studied for flat rolling because the deformation along perpendicular to the rolling direction isn't very important. But sometimes we do need it, and we do need to study it. So in the rotational speed, it did show a quadratic relationship. Therefore, the intermediate values here are the best, are certain to be the best. As for the friction, it exhibit a linear relationship because, and then we would also consider intermediate values here are the best. Lastly, we have strain rate. Both exhibited linear relationships, so therefore we will just consider that intermediate values here are ideal. So simulation results, here are screenshots of the different stages of the process. This is the beginning, this is during, and this is at the end of the process. We have some screenshots of one of the trials. So this is the effective stress, and you can see the profiles of the effective stress and the different regions, red being very high and blue being very low. We also have for the effective plastic strain, the strain rate, and the lateral spreading, and then the rolling force. This is for the upper roller, and this is for the lower roller. So conclusions, we did find the speeds between 70 to 90 RPM are the best. Friction coefficient between 0.35 to 45 is the best. Also, most of the terms were positive linear relationships, and positive quadratic relationships gave us the most information because we did have a minimum value of the measured parameter. So finally, I would like to acknowledge the IEOM Conference Committee for organizing this conference, and UAE University for supporting this research. Also, Dr. Qudeiri and Dr. Aiman Ziout for helping me and supporting me through this work and guiding me through it.